Today's presentation will be on the Riverbed solution for the AEC market, specifically Riverbed's Steelhead WAN acceleration technology. What I'll do in this presentation is just define for us the problem when trying to access files, particularly CAD files, across these slow WAN links, VPN or private line, and talk to you about exactly what these steelheads do to address network latency, which is the real culprit here when trying to access our files across these slow connections. I'd like to point out here that Revit is the big application that everybody's having trouble with right now. We've had successful deployments of Steelhead technology for Revit for many years. Revit does behave differently over a WAN than a LAN, so there are some things that we need to do in order to be efficient and make Revit perform across that wide area network. I'll give you one example. It's the most common error that we find. Not really an error, but it's an issue of workflow. And that is when users make attachments to their Revit models, a good best practice is to make that attachment from the server on which the Revit model resides. The reason that's important is because if a user does a sync to central and doesn't have access to the server or the workstation from which that attachment is made, that user and all users with that issue will see 15-20 minute wait times while Revit is out there trying to locate that attachment, and it can't, and it never will. So users will start seeing errors that the model is busy, check back later, even if there's only one user in the model at the time. It's trying to find that attachment that it can't find, and that causes that issue. So getting back to our presentation here and defining what this problem is. As we all know, when we try to access our CAD files in particular, because they're much larger than a traditional Office document, when we try to access these files over these slow connection, kind of how slowly that red dot moves across the screen is the performance that those branch office users were getting. This is not so much a function of bandwidth and more so a function of network latency, and I'll explain latency in the next slide. But most of us assume that if we just had more bandwidth, this process gets much faster because when we have higher bandwidth, the internet and surfing the internet gets so much faster. Wide area networking is different than that. In wide area networking, bandwidth speaks more to capacity than it does speed. So here's what happens when a user in a branch office goes across that connection and clicks on a file and hits open. That file gets delivered in single packets one at a time across that connection. The server can't send the next packet until it receives acknowledgement back from the branch office user's machine that, hey, I've got that packet, go ahead and send me the next one. This process is defined as network latency. It's that round trip time, the time it takes me to send a packet, get acknowledgement back from the remote computer, and the server to send the next packet. The further apart your office is, the higher the latency, the longer this process takes. It is network latency that we're addressing with the Steelhead technology. So when we deploy our Steelhead technology, and it comes in various forms. I'm showing here two Steelhead appliances. We have a mobile client, we have virtual Steelheads, we have cloud Steelheads. The technology all functions the same. So whether you're accessing data from your data center or you've got a cloud server or a cloud service somewhere, the Steelhead technology all works the same. We're doing three things to your data. When we see that data flow across this connection, the first thing we do is apply compression. So instead of being limited to that very small packet, we can deliver up to a full 1 meg payload with each round trip. So we're eliminating a number of round trips required, making that process a little faster. The big thing we do here is this process called scalable data referencing, or deduplication. So what happens is when data flows over this connection, the steelheads look at the binary information, the ones and zeros, and it caches pointers on the steelhead hard drives here on each side. Now we're not caching your files. We are caching Riverbed proprietary pointers that make up the data in your files. So for example, anytime I see a title block. I'll never send that title block over that WAN connection again, because that title block will exist in pointers on this side, and we'll simply recreate the data from those pointers and deliver it to the user on the high-speed LAN segment. So what happens is you're going to start seeing the data get very skinny as it goes across that slow connection, and then recreate the data based on the pointers that are already stored here and deliver it to the high-speed LAN segment. You may sometimes hear people say how the steelheads get faster as it, quote, learns your data. Well, the more data we see, the more pointers we can create, the more information we can deliver in a single ping across that connection. So you're going to see upwards of the mid 90 percentile range of data being reduced and sent across that connection, and then recreated based on those pointers and delivered to the branch office user here, again on the high-speed LAN segment. Third thing we do is transaction prediction. The steelheads talk together. We don't wait for all the network acts and acts across. We get that information as quickly as we can to the steelhead on the other side based on our compression and based on our scalable data referencing, our deduplication, and again, we're able to deliver that on the high-speed LAN segment to your branch office user. Those are the three things that the steelheads do. So in our traditional file-centric AEC workflow, we would have users here at our data center accessing their files from local servers, and life was great. What we found when we started opening remote offices, how we saw on that first screen, that red dot moving across the screen so slowly, we found that the users out here in the remote offices could not be productive trying to access files over these slow connections. So what we did was basically recreate our LAN out here at the remote office. So we'd copy data out here to the server and provide those remote users with local access to that data. We had to find a way to back all that information up. A lot of times we had data that was duplicated all over. So this did create some additional issues for us. But again, to address the performance problem, we had to do this in order to deliver performance for those remote users. When we start working with project teams that are more dispersed, we've got people out in construction trailers working from home, maybe we've got some consultants that we're working with. Now we potentially have all of these AutoCAD or flat CAD, file-centric CAD users, as I like to call them, out here in our project team. We had to find a way to deliver that information to them regardless of where they were, so they could all continue and work on our project with us. So we turned to these collaboration portals like a project-based FTP site or maybe an Autodesk 360 site or something like that. But the idea was to just simply copy our data up to these portals, give our project team access to it, have them copy the information down to their workstations or local servers where they could begin their work. At certain intervals, we would have everybody copy that information back up to the portal. The project owner would go grab it, bring it all back in-house, start sifting through it, XREFing everything back together, and then reposting it back out here to the portal so that our project team could go up there, download it again, and start continuing on in our process. This was fairly common in a file-centric workflow, but then Revit came about and changed everything. In Revit's model-centric workflow, we had to find a way to centrally store that model somewhere and allow our project team, regardless of where they were, have access to that single Revit model, and again, working with some LAN users here as well. So we turn to the Steelhead WAN acceleration technology. And again, because we're addressing latency, we no longer need those storage servers out here at our remote offices. We no longer have to rely upon those collaboration portals out here. Of course, you can't copy a Revit model to a file collaboration portal because it's not interactive. It's stale. You post it there and people have to download it. In a model-centric workflow, we have to provide access for all of those users on a single Revit model in order to support the BIM workflow. So we do that with the Steelhead technology. For our onesie-twosie users or our single users out there, we utilize Steelhead Mobile. So they access over a VPN connection. We optimize between their Steelhead mobile client and the Steelhead appliance that's in front of the server. Again, makes no difference to us if the server is at your data center or if it's up in the cloud. Latency is latency, and we're addressing that with the Steelheads. So now we're able to put our Revit model here. We've not changed any workflow for the local users here. They're still accessing from local servers, but now we've got our remote Revit users out here, and we've created an optimized environment for them that allows them to go across those slow connections, which are fast now because we have the Steelhead technology in place, and everybody can work together on that single Revit model. Here is a very typical workflow where we're using a combination of Steelhead appliances and Steelhead mobile. And again, I'm overemphasizing this point, but it makes no difference to us where this server resides, in your data center, someone else's data center, on the cloud. Latency is latency, and again, we're addressing network latency with the Steelhead WAN acceleration technology. So just a couple other products you might be interested in. Steel Fusion from Riverbed. If you're concerned about what happens if your WAN link goes down, you might be interested in taking a look at Steel Fusion, which allows us to project our project data out to a remote office. They work on that information locally. If the WAN link goes down, those users keep working. Steel Fusion has two modules to it. The two modules constantly communicate, make sure that any changes that are done at the remote office are stored on the corporate server. So if that WAN link goes down, that data is still local for them. When the WAN link comes back up, the two modules resync together, and any changes that have occurred are pulled across that connection. We always provide a proof of concept. So if you're interested in seeing this work on your own network, we have a 30-day proof of concept available. We'll spec out the hardware or the software that you need if you're interested in Steelhead Mobile, virtual Steelhead, or cloud Steelhead. We'll install that for you. You'll run it on your network for up to 30 days. At the end of that 30 days, if you like it, works well for you, and you want to keep it, we'll simply invoice you at that time. If not, just put everything back in the box and send it back to us, and there's no charge for anything. We run into Revit Server a lot. Revit Server was designed to have the user here at a remote office not have to go across that slow connection, but rather to access their Revit model from a local Revit server. However, the Revit servers still have to communicate with each other over those slow connections. In most cases, if you've deployed the Steelhead technology, Revit Server is not required. However, we have seen instances, particularly with super huge projects, if you have 10, 15 Revit models linked together and you're pulling 400, 500 meg of information across those connections, sometimes the introduction of Revit Server in conjunction with the Steelheads will give those remote users much better performance. The Steelheads in the background will optimize the communication between the two Revit servers, so we're not waiting constantly for that across that network chatter between the two Revit servers. We accelerate that with the Steelheads. So my contact information is there. I'd love to talk to you about deployment strategies, or if you're an existing Riverbed customer and you're not seeing the performance that I've described in this presentation, please get a hold of me, and I think there's probably some things that we can discuss both on the Steelhead configuration side as well as the Revit workflow side. My number is there, and I appreciate you taking a look at my presentation.